you start recording, right?
Yep, we're good to go.
Thanks a lot, first of all, joining this call. Sorry, this meeting. It's also a call anyway. Why I decided to have this training to deliver people in the support team. So you know that sometimes, mostly, we try to finalize the issues without any problem, but sometimes we are stuck with the customers, and when we need help from them. For example, you do your analysis when there is a performance issues. It can be a memory issue or slow performance issues as well. I don't know, it depends. You ask the customers to do something internally, like you suspect that there is a problem with OS, database, network, firewall, I don't know, it depends. And you want them to check, for example, we mostly redirect them, right? We say, please consult your database admins and check for the slow queries or CPU or memory utilization of the database. And you see that a ticket that I shared in my blog post, which is from JP Morgan, they had slow performance issues, especially on create issue. And they said that before it was less than 10 seconds, now it takes around 15 seconds to create an issue. I saw that Arbi was working with them. He did some analysis, and he thought that the problem is database related. That's why he asked their database admin to check something, and then they came back with an update and said that we don't see any issue. In terms of database performance, everything looks good. So he asked them to share an AWR report so that he can check it. Of course, not all of us as database admin, and we are not always working on AWR reports. Me as well. I don't have experience analyzing such reports as a database admin, but we can still do something to help the customers' DBAs so that they can check something on the database level. So this is the purpose of this training. I'm going to show you where to check in the report and what to tell to the customers, or at least to see that if there is a problem in the Oracle database or not. So you know that AWR report is a detailed report related to performance and statistics of the Oracle database. And what happened there? We checked their AWR report, and we saw that there are many cluster weights, which means that they use Oracle REC database. So do you know what is REC database? I mean, does everybody know in this session, in this call? You know it?
And clustered, that is for us there.
Yeah.
No.
So it's a clustered database, or clustered Oracle database. So in the past, it was a single database node, so Oracle databases. So they decided to change the type of the database to perform, to provide high availability on the database side, which is really good. But this doesn't mean that it's always, let's say, good to have it. You know, as you know, that we have some feature requests for DevTools, I think, for Confluence, for Jira. Currently, we are not support REC databases, right? In this case, I checked and I knew where to look at. So I will show you. So I think that will be the main point of this training. And when you have an AWR report, you are going to know where to check in this report first. But of course, in order to understand what is going to happen, or what the section tells you, what that section tells you, I need to tell you more I need to give you more information related to other sections that is in this report. Okay. So as a result, we finalized that issue. We told them that, look, you have REC database. There are many weights happening across the cluster members. So we provided them a workaround solution like separate the instances or use a single instance, or at least have, instead of having active cluster, have active passive one. So create a service on single node, for example, on node one, and send all your sessions to node one. If node one fails, Oracle database, as far as I know, it has a failover algorithm. Move all your sessions to node two so that the client, which means Jira in our case, doesn't understand what's going on, and he can continue working. And before we are going to check what is in the AWR report, I'd like to give you some tips. When you ask a customer to share this report, because this is really important, and not when you ask them share this report, you need to provide some information so that you can help a healthy one. So the first tip is that they need to collect multiple AWR reports. What does it mean? It means that it is always good to have a report when everything is fine. It may happen, maybe the problem is always there, so that you can directly ask, but sometimes they can say that the problem happens during the day between, for example, 10 a.m. and 12 a.m. and after 12 a.m. everything is fine. So you can ask them to generate it when there is a problem, when there is no, so that you can compare the statistics or the sections or any other things in this report. And of course, like in the first one, you need to stick to a particular time when the issue is happening. And split large report into smaller one, which means that you can ask them, or you should ask them to generate this report, for example, for 15 minutes instead of 3 hours or 5 hours. When you, of course, not 2 minutes like we do, for example, 10 seconds or at least, or 5 seconds in the thread times. You can ask for 15 minutes or 30 minutes, like instead of 2-hour report, you can ask 4 reports for each 30 minutes so that you can check and compare them as well to each other. And then the last one, so I told you that direct database in Oracle means that clustered one, and it is possible to have a summary report, like a single report for node one and node two together, but you should always ask and ensure that they don't use RAG, or if they use RAG, ask them to share a report for each node. One report for node one if they have 2 nodes, let's say, and 1 report for node 2. So I think this is one of the important things I want to share with you. And in this session, I am going to show you, tell you how to analyze it, or by going through an example. But before that, of course, in order to understand how to check it, we need to know some terms in this report. I think the most important one is DB time. So when you have this report and check it, you will see, of course, this one. So DB time is, I told you that you can ask them to generate a report for 30 minutes, right? So DB time means that the time spent by foreground sessions. So foreground sessions means here our application is Jira, right? Or Confluence, what else? Atlassian product. DB time means that the time we see in the report, we will see, like, when you have the report, you will see, like, for example, 2 hours, right? So means that all the sessions connect to the database by your application. Here, Jira, I'm going to talk about Jira, okay? So Jira is connected to the database, and then it creates sessions. We call these sessions as foreground. So everything is done by these sessions and spent time in the database, accumulated, and it is marked as DB time in the report. When I show you the example, you will understand, I think, better. So how if we, let's say, drill down into the DB time, we can say, so you can consider it. This is totally almost like that. And DB time means, so if you see a single session or total of the sessions, DB time like 1 minute, okay? So it means that your session spent 1 minute on CPU time, IO time, or other weights. So these are the database related weights, okay? So that's why it's always important. In this report, we will have a section to see how is CPU time, how is IO time, so that we can see that how does other weights look. That's why we are going to focus the three things, which when you accumulate, it shows you the DB time. And we can show it like that. I want to show you. Yeah, so I told you that DB time is the time spent by the foreground session. So what is foreground session? It's at the session that's created by your application. So these are the functions of your application. And then when you do something like click on create button, it goes to the database and came back. So it is this green area is DB time spent by that single session. So this is our single session. And when you accumulate all this one during the AWR report time, I will tell you what it means. This is the DB time. Of course, we do not have a single session in the database. So these are the end sessions that are that spend time in the database during the elapsed time. Elapsed time is the time when you start generating the report, when you end it, like your snapshot duration. For example, we started this session at 9 a.m. and then you ask your database admins to start an AWR. He started at 9 a.m. and stopped at 9:30, and your elapsed time is 30 minutes. So your DB time is, for all these sessions, some of these green areas, and then what you see it. Any questions till here? Okay. So I told you that DB time is the sum of CPU, IO, and other weights. So we can visualize it like this. I told you that we have n sessions in the database, and then these are the DB times, and you can see that we can visualize it like CPU and IO. It doesn't mean that a single session always spends time as CPU, or what it may happen, of course. So of course, when we check it, we will see in the report. But this is just a visualization. So I told you about the elapsed time, that when you start generating this report and then when it ends. So the duration between start and end time. And before we go one of the examples about REC database, I'd like to give another information how we as support engineers, okay, not database admins. Of course, database admins also use this approach, but I told you that we are not DBA, and then really analyzing this report needs many years of experience. It has a huge information, so it's not easy to analyze everything in it, but it is still, we can do something as support engineers, so that after checking these three sections, if you still don't see anything, but you still suspect that the problem is with the database, for sure, if you think that, and if you're right, and the problem is database related, you will see something here. But if not, means that maybe everything is fine, or then wish us good luck to work with their database admins. Okay, the first one is when you have this report, you will see at the top some information about the environment and also load profile. And the second section we need to check and the top foreground events. And the third one is after checking top foreground events, and if we see something or we don't see something, it is still good to check time model information. I will show you. It sometimes reveals something which we are not able to see in the top foreground events. So these are the things I want to tell you. As I said, we are not going to deep dive a report, so we will approach it like a support engineer. And there are 3 different sections that I told you right now. And most important thing that we are going to check is DB time. And DB time is accumulation of CPU, IO, and then also other weights on the database level. So here is an example. And then in this example, we have 2-node rack. And this is just to help us understand what is AWR report and how we can read it. I want to share this screenshot, and I highlighted something here. Do you see, I mean, when you check this one, so this is summary of the environment. I told you that the first section is, we need to take a look, is summary of the environment. What do you see here?
I guess general information about this report and the database itself.
Yeah. Okay, any other ideas? I mean, there are some more information I will tell you, of course, but I want to see, for example, we don't know anything, but when we check, there are some information, as Alex said.
There's 7 minutes DB time, I can see.
This is 1,000 actually, not minutes. Yes.
7,000 minutes. Oh, sorry.
Yeah. Yeah.
Right. So was this collected over like a large period of time or long
Yeah.
period of time?
So this is elapsed time. You see 200, more than a bit more than 200 minutes.
Right.
So yeah, thank you. So, okay. I told you that when we ask customers to share a report, if it is a REC database, share a report for each node. So here we have 2 different summary of each node. So this is, you see, instance number 1 and instance number. So this is node 1 and node 2. And I told you that the first thing we need to check, of course, when we check DB time is 7,000 something, it doesn't show anything here, right? There are some other sections. And for sure, it is not the first section when we have the report is going to take, that we are going to take a look. We will check another section, but of course, after checking that one, we can come back to the summary of the environment and check how many, for example, CPU cores it has and what are the session count and so on. So yeah, this is the summary of the environment. We see that it's a REC database. It says yes, because we have 2 nodes. And then this is, sorry, this is the release of the database, instance number 1, number 2. And we began to generate this report at 10 a.m. And we started at this time, more than 3 hours, 3.5 hours almost. So as you see that, this is the elapsed time. And a bit more than 3 hours. And during these 3 hours, all the foreground sessions, means that the sessions created by your application were working in the database, and they spent 7,000 minutes in the database. It can be CPU utilization, it can be IO, or it can be other database related weights, okay? And so we see that in total, database has 40 CPUs and 20 of them are on node 1 and 20 of them are on node 2. And so we see the total sessions in the database when we started. And then when we ended, this is the snapshot, okay? So at that moment, 2100 were in the database, and again, around that number of the sessions there. One important information, let's say you suspected connection leaking, okay, in the database. You see there is a section cursors and sessions. So when you begin snapshot, the open sessions, I mean, the active session at that time was 1.1. This is the average, okay? And when you end it, it was again around that number. So if you suspect connection leaking, then what you can do, you can ask them to share a report, then you can check if this number is increasing. But not only two different, one report is enough. Maybe you can ask a few reports. You can see the trend of the open cursors or sessions. If it is going down, it is going up, or it's always constant, or it changes. So this is an important section to check for the connection leaking. Okay. Any questions regarding this summary of the environment?
What do you mean by connection leaking? And what is
so it's like that. Your application connected to the database, right? And it gets connections from the connection pool. And when you do something, I mean, actively using that session, so sessions can be idle, means that ready to be used by your application, or it can be active, means that your application is doing something, and feeding this report with the DB time means that they are actively being used. And it may happen you get a connection from the connection pool. I mean, your application Jira gets a connection from the connection pool and did something. After you finish what you do and click on create issue, and everything looks good on your UI, and you say that, okay, Jira is working, and then I clicked on the create button, and then I see the pop-up window to fill some information about the issue, that ticket that I'm going to create. But it may happen that when you finish your task and you logged out Jira and you're not actively using that session anymore, but your application didn't close this. So it took in the database, it looks still a busy session. So what happens? You for example, your connection pool is set to 20 active, maximum connection, 20 connections. So one of them is get by this one. So another comes, we'll take another one, and means that your application finishes what it does, but it doesn't give the connection back. So you will see the number of course, you will see in your connection pool setting, connection pool is statistics as well. For example, in Jira, we have on the system page, the database connection pool is statistics for the last 6 hours. If you suspect that one, you can check on the database level by checking this one. Of course, this is not the only way to check. Before that, you can do many things, like to ask the customer to share active sessions in the database to see what kind of SQLs are busy or who holds it and so on. But this is another section you can check it for the leak connections.
But like we said, cursors and sessions, what would be indicative? Like what would we see if there's a connection leak? Like,
so
will the session go up, or what's going to happen?
Yeah, for example, here we see that it is always less than 2, and then at 10 a.m. it was 1.1. This is average, just the calculation, and then 3.5 hours later, it was still same. Means that we don't see anything in these 3 hours, and the connections are used and released back, reused and released back. For example, you generated 3 different AWR reports between 10 a.m. and 11 and 12 and 1 p.m. And you check these sessions, 1, then you saw 10, then you saw 20. And if it is going up, if there is a leakage, for sure you will see a trend going up. Then you can suspect a connection leaking. And of course, you need to check your how it looks like on your database, sorry, application side as well. And you can see it in the thread dumps, or even at the end, generating a heap dump will help you to analyze it.
Okay, thank you.
Yeah.
And about the elapsed versus DB time, how
Yeah.
come is the elapsed so significantly smaller than the DB time? Is it because of the CPUs? Like,
So you ask why DB time is bigger than elapsed time?
That's correct. Yes.
Okay, so I told at a few minutes ago that elapsed time is when you start generating the report 10 a.m. and when you end it, but there is no a single session connected to the database, right? For example, here 2,000 sessions are here, and then one of the sessions I did a task in the database and spent, for example, 30 seconds, another one 10 seconds, another one 5 seconds. So this 7,000 minutes means that during this 3.5 hours, all the time spent by all these sessions, not a single session. It doesn't mean that it cannot be higher than elapsed time. This is very quite normal.
Okay, thank you.
Okay, yeah, thanks, you too. Any other questions?
Yeah, I have a question. When we looked at the snap time, there's a begin and end. I assume this is database time. How do we match it with, how do we know if it's actually in UTC or something else to match with the log?
Yeah, good one. Actually, I don't have this information in this report currently, but so we need to check. I mean, system time maybe. I didn't expect this question to be honest.
All good.
So,
I usually ask the customer, just want to make sure, want to check if there's anything inside the AWR report to call this out. Thanks.
Yeah, thanks, you too. Okay, so we can continue. And we checked the summary of the report. Then I told you that the other section is load profile. So here I highlighted something. Of course, there are many other sections that we could check, but I told you that we are not DB admin, and I just highlighted something that is important for me. So basically what we expect database admins to help us by analyzing this report, right? So why we now do this? Because we sometimes reach out our limits, and then database we had to rely on what database admin says. But if, for example, if we didn't check AWR report in JP Morgan's case, we will continue working internally and try to understand what's happening. So that, as I said, that there are some more informations we need to take a look. But in this report, I want to show you this one. So the first thing is DB time. So DB time per second. What is 34? It's like when you divide. I can close it and show you here. Yeah, here. So on the node 1, we saw that elapsed time is 206 and DB time is 7,000. So when you divide it, you will see we can call it like a load average in Unix. Of course, it's not same. Just to see that node 1 and node 2 are accurately balanced or accurately loaded or not. So it shows the DB time per second. So, but one of the most important here is DB CPU. So you see that on node 1 it's 3.6 and on node 2 is 9.2, which means that when you check this metric, DB CPU here, do you think that there is a CPU problem on this database? Remember, we checked summary of the environment and then load profile. And now we have CPU section or information here. And after checking this, do you think that there is a CPU problem or not?
Well, there was over 7,000 seconds total time, but we're only, or minutes, but we're only
Yeah.
seeing 34 seconds here. So I say no.
So actually, I was asking about CPU. So you remember that we have 20 core on each node. So 20 core on each node, and 3.6 and 9.2 on each node are in use, which means that the database does not have any CPU problem. So we still have CPU left over. Like you know, our Jira server has 20 cores and then load average is like 10, which means that around 10 cores are still available to work. So the same as here, the database does not have any CPU problem because this one has 20 cores and more than 16 of them are available, and same as here, more than 10 of them are available. So after checking the load profile, we now know that there is no CPU problem. And remember, the B time is accumulation of CPU, IO, and other database related weights. So if you think that there is no CPU problem, and you can think that we can exclude CPU time from the DB time. So now we need to think if there is a problem in terms of IO or other database related to weights, if we suspect a database problem, okay? So let me check someone. Okay, Zul and David. Okay, so another thing I highlighted, global cache blocks received and insert on each node. So you see that received on node 1, which is sent by node 2, and then sent by node 1, received by node 2. Means that, yeah, this is a rect database and the nodes are communicating each other. So global cache related events are here. So I want to tell you what is global cache related event. So in the rec database, of course. So, okay, you connected Jira and then your session is get from node 1. So the things that you are going to make, like selects or maybe changes, updates or inserts, is going to happen on node 1. Any changes happened on node 1 by your session needs to be cached also by node 2. So you made an update and on node 1, and at the same time, or maybe a few minutes later, another session came to the database over node 2, and they also want to get current value of the column that you updated on node 1, or maybe they want to make another update. And the database says, look, the master of this record is currently node 1, and please go to node 1 and check with him. So in this case, node 2 communicates with node 1 and asks for the current value of the record that it is trying to record, check it. So this single event is called as global cache event. And we see that these nodes are communicating each other. And during this elapsed time, 27 and almost, I mean, around 3,000 events happened between the cluster. So still, by checking this one, we cannot say, okay, there is a problem, but looks like this application is chatty, like each node on the database. Node 1 is doing a change, node 2 is asking for this change. So that's why we see this global cache related event. So it's kind of Jira data center cluster replications, something like that. Any questions related to this? Okay.
Yeah, just one question.
Yeah.
So is the global cache exclusively to rack, i.e. multi-node databases?
Yes. Yes. Yeah, you will see that if you have a rack database, or, I mean, more than one node database. So another thing we need to check, or we can take a look, parses. So there are two different parses, hard parses and soft parses. Parses means that when you do something on the database, and this, if it executes a query, it can be insert, update, delete, what else, and it's always counted in this report as a parse SQL. But if it is not executed, means that cached by your application, you are not going to see it. So here we see that a lot of parses means that there are some SQLs executed again and again. Means that you select a value from a table, like start from table 1, where ID is 1. So you selected this, and then another session came, and he wanted to select this one of that. So this means that your application does not cache the SQL, and then it is going to the database to check again. So you know that we have some statement cache on the application server. So I drop a link about it at the end of the session, so we will see what I mean. I will show you in the example, but looks like there is a parse problem, and we always re-execute some SQLs, and also hard parses happening on Node 2. Hard parse mean that hard-coded SQLs in your application, like instead of using bind variables. By the way, do you know what is bind variable? So when, for example, when you analyze, sometimes when you ask the database admins on the customer side to share active SQLs or long-running SQLs, then sometimes they share like select star from in the var class. You will see ID like 1, and there is no value, but there are some. Maybe I can show you. Yeah, so I'm going to check if I can show you anything related to it. So it's you will see like that, okay? So these are the bind variables. So SQL is the same, only the value is changing. But hard parse means it's like you have some SQLs in your application, and it is hard-coded, and you cannot change it. You need to consult your development team to change it and convert it to the bind variable so that you can cache it. Otherwise, you need to execute it always. Like in this case, select star from orders, where order ID is 12, for example. You always have this one in your code, and if you execute this, it is going to be counted in hard parse section. So it means that we have during this time we run around 38 SQLs, which are hard coded in the code. So you need to consult your development team. This is not database related. And the last one is rollbacks and transactions. So transactions means that after checking this one, we can understand how many transactions are sent to the database and how many of them are rollbacked. So if you suspect that there are some failed transactions, and maybe a lot, and then you can check it. By the way, transactions means that, you know, PL SQL blocks begins with begin and ends with end. So everything, it doesn't matter, maybe 1,000 inserts can be run between begin and end, but still this is counted as a transaction. So it is not 1,000 transactions. The transaction is the blocks of the queries or updates or inserts that happen between n and begin and end. So yeah, means that on node 1, 1,400, on node 2, 1,900, and 43 of them on node 1 and 29 of them on node 2 are rollback. So if you suspect some rollbacks in your application, you can check this one with your database admin. Yeah, and so you see that we said that there are 3 different sections we need to focus, and we just check one of them, and then it is summary of the environment plus load profile, and we check and we see that there is no CPU issues, so everything looks good, and then the majority of the database, I mean DB time, sorry, it is wait, so it can be IO wait or database related waits, right? Because we now know that there is no CPU problem. So after that, we need to check top foreground event sections. So this is, sorry. Okay. I think you know that, you remember at the beginning of the session, I said there is a section that I'm going to tell you what to take a look to understand if something is wrong with the database or not. And it is this one, top foreground events sections. So you see that there are some information. I'm sure that currently it looks super confusing for you, or it doesn't mean anything, or maybe it does for some of you. But when you have a report from the customer, please open it and go directly to this section to check if you see DB CPU and IO, the first 2 events or not. If DB CPU and IO is not the first 2 of them, then for sure something is wrong with the database. But if you see DB CPU and IO at the top, and of course, if their, let's say, percentage is not 100%, you can say that everything is good in terms of database. But here, we see DB CPU here, but it's not at the top. We also don't see any IO that's happening on the database. Here we see DB CPU, but there is no IO, plus there are, this is GC means that global cache events, okay? So remember, we checked load profile section and we saw some global cache related activities that is happening between the cluster members. And we suspected something, but we didn't know still there is a problem or not. That's why we came here to check it. And in the event sections, we don't see DB CPU and IO at the top. So if you have DB CPU and IO, and if you see you see at the first 2 of them at the top, now we can go back and, okay, we check the CPU in the load profile section and there is no CPU. Then is there IO or not? So maybe IO is at the top and it's 100%, right? Then you can say, okay, IO happening on the database, it can be because of high load, or maybe there is a problem with the database disks, and or you need to ask database admin, okay, I see that there is an IO problem, for example. But here, for sure, we don't see anything. There is no IO issue, and we know that there is no CPU issue. What we see, even on node 1 and on node 2, there are many GC-related activities happening. And this means that we need to focus on this. So why it's happening? And then these are some details. For example, here it says that at the top, index contention is happening. Means that on node 1, index maintenance is happening. It can be like database admin is doing some index maintenance at that time, or due to some SQLs like inserts or updates, it causes index contention. So indexes on this database are needed to be updated or maintained by database. So Oracle database, as far as I know, it has some, or maybe other databases as well, has their self-maintenance system, and then they need to rebuild the statistics on the table so that it can perform well. But it spends a lot of time here, and we see GC-related events, okay? So now we suspect something. We know that CPU is good, and we don't see IO here. Okay, I will show you in the other section and then we will be 100% sure that the problem is database related. So I skipped this one. This is about index contention. This is just an example, but so I want to show you this one. In the screenshot, you see that I told you that I still believe that there is a problem with the database. And now how we can verify it? You see there is CPU section here and IO section also. And remember, DB time is sum of CPU, IO, and also other weights related to database. And this is the most busy SQL. So we have SQLs ordered by the elapsed time. And you see CPU count for this one, CPU percentage, and then also IO. You sum both of them, and it is less than even less than 300, right? Means that for this insert, 97% is other database related weights. And here's as well. So this is the most busy one, for example, if we compare, like less than 50% for this select, but still it is not compared to this insert, it doesn't consume a lot of time in the database. And we can see that most of the time spent on the database is other weights. So what we did, we checked top foreground events, then we came to global cache weights section. So it means that here we suspected the problem is global cache related activities, but does it happen because of CPU, IO, or database itself? And we check CPU and IO. So now we are sure that global cache related activities happens because of the database. So, and we know that it's a rec database, right? In this case, how we can fix it? And there are two things we can do. One of them is you can change your application so that it can support rec. So for sure, in this example as well, this application does not support rec database. So we can change our database and our business logic and all other table structures to support this. This is a development task, and I don't know how to tell you what to do about it, but for sure, we have for example, for Jira, we know that it doesn't support, and we have a feature request so that customers can use rec databases. And as far as I know, we have open feature requests for other applications as well. Or what you can do, you can say that don't use rec, use a single database. And in order to avoid or remove these weights that are happening on the database level, you remember one of you asked me if these weights are because of the rec database or not. Yes. So if we use a single node database, means that we are going to remove all these weights. We are not going to check. So after that, if you ask your DBA to generate a new report, for sure you are going to see, you are not going to see this. So this is the approach. So of course, it's not easy to change your application quickly. As a workaround solution, don't use rec. So this is what we also told JP Morgan. So you remember that I also talk about the SQL parsing problem. So we have a section that shows the SQLs, parsing, soft parsing and hard parsing. I told about hard parsing, that hard-coded SQLs that are in the code. So you need to, if you see in the report, you need to ask your developer to change them and to use bind variables instead of it. But we saw soft parsers, then we can come to soft parsing section. We have it in the report. Then what we need to do is, these are the parse calls and these are the executions. So in a normal report, we should see less executions, and parsers should be less than it. So we need to, sorry, the executions should be less, but here we see almost same for this SQL. Then we have SQL IDs, means that you can, in report, you can go to SQL sections and check for this ID. You will see the detailed SQL, so that you can go to, if you suspect something about that SQL, you can talk to your developer, or you can talk to either your database admin. But here we see that almost these SQLs almost executed again and again. They are not cached. So you know that in the application service, I work with WebLogic. Now we are working with Tomcat. There is statement caching feature. So I attached here how to do that. So you can implement it on your application server, so that you can avoid this problem and the waits that are happening because of this one. Yeah, I think this is all I can tell, and I hope it is. I could tell you something, but yeah, this is all I can tell you. I appreciate it that you joined, and I am happy to listen to you if you have any questions. Any questions or comments?
I guess just a comment to say thanks, Alp. You really deep dived into an area that I hadn't focused on in the past. Typically, I would just go straight to queries by SQL time or CPU time or IO wait, but you've really explained actually we need to step back and look at the bigger picture about, you know, other causes potentially in the instance health overall. So
Good.
yeah, thanks.
Yeah, thanks you too. And any other questions?
No questions, but certainly a comment. I'm going to watch this replay again multiple times, so most of it sinks in.
So James, you know that I mean, I mostly prefer to work in the morning. So I mean, this is for all of you. You can still check the record or this blog post, but please reach out to me if you have any questions. So even I don't know, I will try to find it. So at least.
Thanks a lot for that.
Yeah, thank you. Okay, and thanks a lot for joining the meeting again and one more time, and have a great evening.
Yeah,
See
thanks
you.
a lot. Bye-bye.
Bye-bye.
Thank you.
Thanks, mate.
Bye.